Welcome to Syklo's world. We're helping companies to solve modern world's requirements to reduce carbon footprint in production. By the way, we make wonders out of waste.
Well, good afternoon. My name is Eero Martikainen, and I am very glad to be here today to present you our company, Syklo, and discuss how we are changing plastics circularity, or redefining it. I will start by shortly introducing our company and what we do. We, as Syklo, are a supplier of high-quality circular materials. We are investing in Nordic's largest PCR recycling plant and world's leading biocomposite plant, both opening Q3 this year. Total investments in Hyvinkää, Finland are over 70 million euros, and the capacities will be 50,000 tons of PCR plastics as well as 8,000 tons of biocomposite master batch. Well, why are we on this journey? We have seen that there are some key challenges in increasing the plastic circularity. We have seen, as you all probably know, recycling mixed plastics has been difficult to do economically. Sorting different plastics from each other and reaching good quality products has been challenging, which has led to a market where when you produce a PCR product or material, PCR plastic material, you usually need specific feedstock, and you're dependent on getting that feedstock in. Also, black plastics have been challenging to sort from these mixed streams, as optical sorters traditionally haven't been very good in identifying different polymers from each other. Also, quite often, recycling still is downcycling, or has been, which means that mechanical properties are lost and value decreased. Also, quite often, PCR products have quite high variance in terms of mechanical properties, which make it difficult to use in demanding applications, where this variance is not okay. And we are here to change the narrative with our next generation plastic recycling plant and our products, Sykloplast, or PCR products. In our plant, operational this year, we are turning plastic waste into high-quality materials for demanding industries and demanding applications. We are focused on maximizing the product quality. And the whole concept is based on using mixed plastic waste, which means that there is feedstock available, and we are able to supply. In the facility, we are utilizing various next-generation technologies, some of them being utilized for the first time in our plant. As said, as a feedstock, we use mixed plastic waste, mixed rigids and mixed films. And as products, we produce Sykloplast PP, HDP and LDP pellets for demanding industries, as well as side streams, some flake products which we are then selling for other recyclers to sort further. As said, we're utilizing several cutting-edge technologies which enable the quality of our products. First of all, the main sorting is based on densities, which is color agnostic and makes it possible to also sort the black plastics to our products. Also, most of the process is based on water, which means that we are washing the plastics over and over again in many different steps. As it is based on usage of water, we have also built closed-loop water management system, so we are not producing any wastewater from this plant. Also something quite new in the industry. In addition, we are using color sorters as well as optical sorters to even more improve the quality. And also, the extrusion process is innovative, enabling the good quality of our products. A little bit deeper into our process and what makes us different. Well, we start by washing and grinding, quite typical in the industry. We are grinding the plastics to flakes, and we are washing the flakes. But then we go for density sorting of these flakes. We sort out different polymers by their density differences. Once these are sorted and washed, we do the color sorting and utilize optical sorters to reach even higher quality. And the feedstock, as said, is mixed rigids and mixed films. Then after we have the flakes, PP flakes, HDP flakes, and LDP flakes, we go to the extrusion process, rather innovative one, where we utilize both single screw and twin screw extruders, which enable us high quality and very high tailorability. Our first products look like this. We have a couple of grades in PP, what we are working with, as well as HDP and LDP. The key thing here is, you can see the melt flow index, what we have in these products. This is just the starting point. In our solution, we can tailor, for example, that to our customer needs. We have high tailorability in terms of that, but also in other properties. Common in our products is low VOCs, and they being stable to process. We can tailor the product, and we can narrow the variance windows so that our products are easier to use in conversion towards recycled plastic products. Then, as I said, we are also building a biocomposite plant. Syklo, how we call it. It is a master batch production plant, and we produce 8,000 tons of master batch, which means between 14,000 and 40,000 tons of ready compounds, what our customers, compounders on this side of the business, can do. And we will be expanding the capacity rapidly in coming years. You might wonder, why is this relevant for users of PCR plastics? Very understandable question. Well, our biocomposite, I want to highlight our biocomposite. I will talk a little bit later how this differs from many other products available on the market. Will enable usage of PCR plastics in areas where it has been difficult before, whether that is because of mechanical properties haven't been met, etc. And with this biocomposite, we are not replacing, for example, polypropylene. We are replacing reinforced plastics, other reinforced systems, or technical polymers. Also, in our biocomposite, we can use recycled fibers as the feedstock, increasing the recycled content of the final products and materials. Also, our biocomposite is actually well recyclable. You can recycle that up to 7 times without losing mechanical properties. Also, we are working with such concepts as shown here, working with sort of a closed loop circularity, where we can take, for example, packaging waste, for example, cardboard, use that as a raw material for our products, and then sell that to be a part of our customers' application. Well, more in detail, what is our product, Syklo? It is a reinforcing additive to replace, for example, glass fiber or technical polymers such as ABS or PC ABS. What we use for our product and what it contains is 70% fiber, which can be commercial pulp or recycled fibers, for example, from cardboard. And then 30% virgin polymer or PCR plastic. Quite typically, we are talking about PP, but we have done a lot of development with other polymers as well. What does our innovation enable? High mechanical properties, lower carbon footprint, and commercially competitive solution. And this is important, because this has not been sort of the status quo with biomaterials. Key benefits is a bio-based reinforcement system. And a key here, we are getting to the point where you can start to learn how this differs from other biocomposites, is a 3D reinforcement network, what we are doing. First of all, the reinforcement is more or less the same to all directions in the product, which is very different, for example, when you compare it to glass fiber, bringing you design freedom, and you can optimize your products. Then, using biocomposite leads to faster production time in conversion. In long-term applications, it can work as a carbon sink, but that always depends on the application. And it is recyclable. But mechanical properties, that's something what makes us different, as well as very good dispersion of the material. Our process looks a little bit like paper machine. We use water in making this biocomposite, and that's a key difference. We are mixing the fibers and polymers in water and pre-dispersing the polymers and the fibers and coating the fibers with polymer, which means that when using our products, you don't have agglomerates. That's one thing. Also, when using the water, we are protecting the fibers. We are ensuring that the fibers are not cut too small, which means that you would lose some properties and strength of the product. We are also increasing the surface area for improved chemical compatibility. But key thing is optimal entanglement. In our process, we make the fibers to entangle to each other. So instead of having single fibers, we have a network of fibers, which are entangled to each other mechanically, but also chemically, which gives us exceptional properties. And that we call 3D fiber network. This is what it looks like, this 3D network, what we do. On the left side, you can see cellulose fibers before our process. Individual fibers on top of each other, but they are individual. In our process, we fibrillate the surface of the cellulose fiber and expose the microfibrils, which enables the fibers to attach to each other. And this gives us strong fiber-to-fiber binding. Why is this relevant? 3D reinforcing fiber network and good dispersion enable the high mechanical properties and wide usage in a wide range of applications. Target applications typically where our biocomposite can be used are automotive industry, electronic industry, and construction industry. But it's not limited to that. Wherever you need higher mechanical properties, and if you want to use a recycled material for the reinforcing, our biocomposite can be a great solution. Couple of examples what we are doing, what we have done in the market. Climecon is our customer who is producing ventilation systems. Previously, they were using a lot of technical polymers to reach the properties what they needed. For example, PCABS. We started a development work with them. We worked for some time and found solutions where they can replace the PCABS with our biocomposite based on PP polymer. EcoAims is another example of a company. They're making making laser guns used in sports, and they've been using our material for handles of those products. We have various other commercial applications as well, what we have been doing already with our smaller capacity. With the biocomposite side, we've been operational with the smaller capacity for quite a while. But Syklo and Syklo, what does that bring for our customers and demanding value chains? First of all, with Syklo, we are bringing a stable PCR-based polymer tailored for customer need. With Syklo, we are bringing recycled reinforcing system. Together, these we like to call us as one-stop shop for companies producing PCR compounds needing high mechanical properties, and these work very well together. This increasing plastic circularity is about partnerships and working together throughout the value chain. That's what we believe. And we believe that together we can make wonders out of waste. Thank you very much. And if you have any questions, here is a link for that. And I can try to reply. Well, it seems there's no questions unless someone is writing a question right now. Okay, thank you very much. I'm happy to discuss later after this if you still have something to ask about. Okay, thank you for listening and have a great rest of the show.
Welcome to Syklo's world. We're helping companies to solve modern world's requirements to reduce carbon footprint in production. By the way, we make wonders out of waste.